Hi there, Dave here about our Fibonacci function that we wrote, how it works. And before we get into that in the Python code, I thought I'd show you what I found on the web. Here's a Fibonacci sequence in music. It's kind of interesting. Well, I thought it was coming up. Anyway, you have some arpeggios in Fibonacci. Pretty interesting stuff. Actually, this is a foundation sequence for a lot of the universe. So, math can be interesting. And so let's see how it all works. Well, it's all based on this Fibonacci sequence, and this is it. And the sequence says that like this 21 is based upon the fact that it's 13 plus 8, and this 13 is because it's 8 plus 5. So the Fibonacci of 8 is equal to the Fibonacci of 7 plus the Fibonacci of 6. And so we're going to write the function. There it is. There's the fib function. Fib says if the number you're passing in is 0, then return 0. If it's a 1, return 1. Otherwise, return the Fibonacci of the number that you passed in minus 1 plus the Fibonacci of the number that you passed in minus 2. And that's exactly the pattern that we just described above. And that's how it works. But it's pretty complicated how it actually works. Let's take a look at the Fibonacci of 4. Well, the Fibonacci of 4, when we throw it into here, it says, well, n is not a 0 or a 1, so it executes this. And so that executes the Fibonacci of n minus 1, which is 3, plus the Fibonacci of n minus 2. And so what I've shown is the mathematical equivalent of that, saying that the Fibonacci of 4 is equal to the Fibonacci of 3 plus the Fibonacci of 2. And then on the next line, I say that, well, the Fibonacci of 3 is actually the Fibonacci of 2 plus the Fibonacci of 1, and the Fibonacci of 2 is actually the Fibonacci of 1 plus the Fibonacci of 0. And then further reducing as far as I can down to Fibonacci's of 1s and 0s, I come down to the next layer. Well, the Fibonacci of 2 is actually the Fibonacci of 1 plus the Fibonacci of 1. And then there's our original plus Fibonacci from the previous line. Yeah, that gets carried over. Plus the Fibonacci, and that hasn't been reduced anymore. So when we get down to this bottom line, and we reduce everything to 1s and 0s, we see that we got the Fibonacci of 1 is 1, and it's a 0 there, and a 1 there, and a 1 there. And so if we add up all the 1s, we come to 3, and it says the Fibonacci of 4 is equal to 3. And if we look at it, yep, that's what it says right there. It's equal to 3. And so if we do the same kind of silliness with the 5, we see that the Fibonacci of 5 is equal to the Fibonacci of 4 plus the Fibonacci of 3, and that C shouldn't be there. And the Fibonacci of 4 is actually the Fibonacci of 3 plus the Fibonacci of 2, whereas the Fibonacci of 3 is actually equal to the Fibonacci of 2 plus 1. And the Fibonacci, and eventually you come down to the Fibonacci of 1 plus 0 plus the Fib of 1 plus 1 plus 0 plus 1 plus the Fib of blah, blah, blah. And to add it all up, it comes up to that the Fibonacci of 5 is in fact 5, because there's 1, 2, 3, 4, 5 1s in a row. And so each time the Fibonacci function is called inside of the Fibonacci, it actually starts a new Fibonacci function someplace in memory, because the variables that are being used inside the n's are all different every time it starts a new instance of the function. So this is recursive programming. This is what we do with Hasp and Haskell and Lisp and other kinds of functional programming languages. But you can also do it with Python. You can also do it with JavaScript and Java. You can do it with any language. Take care.